Hello, and this is Chapter 6, Environmental Quality in Anderson's Environmental Economics and Natural Resource Management. And you see here, as in the book, a picture of the world and projected sea level rise, sea level change for the years 1993 to 2012. And it shouldn't be any surprise to any of us that sea level rise is definitely on the rise. Global climate change has warmed the ocean and melted land ice, raising the mean sea level by 2.2 inches between 1993 and 2012. The rise is not uniform, though. You can see in red where the rise is greatest, um, and and where it's blue, it's not so much. Looks like Hawaii, not nearly as much as places like New Guinea and the north coast of Australia. But that doesn't mean that we in Hawaii are not dealing with sea level rise as well. Just ask anybody who lives on the coast, um, on Oahu, especially on the northern windward side, or even some of the other islands. Now, the United Nations Environment Program tracks countries' pledges to cut greenhouse gas emissions. The emissions gap in 2017 is actually lower than it was in 2016. So progress has been made, but much more progress needs to be made. Now, this chapter is going to go over terms to measure environmental quality and summarize foundations for mutual understandings and case studies about possible solutions. And speaking of terms, here are some important terms to know. And I'll just be reading these directly from our book here. Number one, an environmental sink is a repository for potentially damaging byproducts of human activity. So we can send a certain amount of products into the sink, but we cannot and should not overflow the sink as well. So now that leads us to next term, something called carbon sequestration. So carbon sequestration, you can sequester or store the carbon in the sink. Is a part of a set of reactions known as photosynthesis, in which solar energy, carbon dioxide from the atmosphere, and water combine to form carbohydrates that are the building blocks of biomass. So there is a natural amount of carbon sequestration that happens, but we have to have enough of the environment available to give us that carbon sequestration. Okay. So, and a process called carbon sequestration, oceans and vegetation absorb carbon dioxide, release oxygen, and store carbon. And when there's not enough oceans and vegetation, there may be too much carbon released into the atmosphere, and that is a part of what we're experiencing now called global warming. Natural capital. So this is to designate it from physical capital. Natural capital includes natural resources and ecosystems that provide clean air and water. Natural capital is susceptible to resource degradation from the overharvesting of natural resources and pollution that results from the exhaustion of environmental sinks. And that leads us to stock pollutants. And stock pollutants quickly overwhelm environmental sinks and accumulate in the environment over time. So these are stock pollutants that are stored and are measured as a stock. So you can measure it at a point in time. Examples of stock pollutants are PCBs, dioxin, DDT, and heavy metals. Now, natural pollutants. Oh, by the way, I should say that stock pollutants are to be distinguished from flow pollutants. Um, but while stock pollutants may remain in environmental sinks, flow pollutants are initially damaging but are dissipated into environmental sinks with relative ease. Examples include light, noise, and heat pollution, biodegradable litter, and smog. So, a stock pollutant would be very, very difficult um, to absorb, but flow pollutants would be much easier um, to handle. Okay, so natural pollutants are harmful emissions from the earth and its creatures. So these are natural pollutants that occur as a result of living. So animals can create pollutants as well as humans can. So your book talks about volcanoes and bubbling springs emitting large amounts of carbon dioxide. Decaying plants emit methane. Cattle emit methane. Ocean and bacteria release a third greenhouse gas called nitrous oxide, and animals, including humans, emit hydrogen methane. The main point is that pollution is not just by driving cars, pollution naturally occurs. Now, anthropogenic pollutants, these are pollutants that occur as the undesired byproducts of human activity. So when humans manufacture goods, transport themselves and their possessions, cool and heat their homes, turn on their lights and electronics, they are definitely generating pollution. Now, stationary and mobile source pollutions. Um, Pollution coming from a stationary source, a power plant, or a mobile source like a motorboat has implications for pollution control effects. It's easy to monitor the output of stationary sources, much more difficult to monitor the output of mobile sources because obviously they are mobile. Um, so for source pollution, the trick is to regulate the fuel that goes into the mobile source as opposed to regulating the effluent that comes from the mobile source. Okay, point and non-point solution. A point source is an identifiable source of pollution, like smokestacks, effluent pipes, and leaking oil tankers. Non-point source comes from diffuse sources that are not identified. Um, Runoff of rain, melted snowpacks, picks up pollutants like fertilizers, herbicides, and the like, and so you don't necessarily know where the pollution is coming from. Uniformly distributed pollutant causes the same environmental damage regardless of where it is released. Examples are greenhouse gases, which is carbon dioxide, methane, and nitrous oxide, and the like. The greenhouse effect is these gases trap heat in the atmosphere and thus heat up the planet. Now, concentrated pollution causes damage primarily within a local area. So this is a city creating noise, light, and smog that is unlikely to cause much damage beyond the urban boundaries. Now, a non-uniformly distributed pollutant causes harm elsewhere but has a relatively large effect on the local area. For example, nitrogen from fertilizer and other sources runs into the Mississippi River and draws oxygen from the water. The resulting hypoxia is deadly to agriculture and has created a dead zone covering over 7,000 miles of the Mississippi Delta. So this is non-uniformly distributed pollution. Whew, that was a handful, and that is just 2 slides. So now let's get on to aha. This is a picture, and it is in your book, and this is Trash recklessly dumped beside a road in the United States. So this is environmental degradation, and this is I guess it would be a I guess it would be a I don't know, non-uniformly distributed pollutant. Now here we have an example of pollution from a stationary source. This is coming from a oil refinery, and so one knows where this is coming from, whereas in the previous picture one does not necessarily know where where the tires are coming from. Now here we have an example of a large pipe directly dumping into the ocean in Mumbai, India. This is a point source of pollution, and so it's identifiable and can be indeed targeted for cleanup. And here we have examples of uniformly distributed pollutants. So it has both distributed in the local area as well as elsewhere. Concentrated pollutants in the local area with no damage outside, and non-uniformly distributed pollutants, heavy damage in the local area, but not so much heavy damage outside of the local area. So those are pictures showing those various things. Okay, that finishes part 1 of this chapter 6.